Look up into a clear night sky with your naked eye, and what planets could you see? Technically, you would be able to see all of them at one time or another, all of them apart from Neptune. It is the smallest of the gas giants, and also the furthest away, and it is a perplexing place. You would think a planet so far from the Sun wouldn't have a dynamic atmosphere that exhibits ginormous storms and super fast winds. So why is this planet as interesting as it is? Let's start right at the beginning. Neptune is the only planet found through mathematical prediction. You see, when Uranus was discovered and astronomers were plotting its orbit, they noticed that Uranus wasn't following their models. From the perturbed orbit of Uranus, Urbain Le Verrier in 1846 concluded that there must be another undiscovered planet, and he predicted where it should be, and remarkably, Johann Galle was able to find it only a degree away from the predicted point. Triton, Neptune's biggest moon, was discovered a few days later. But since then, Neptune was little understood, as its distance from Earth and very small apparent size meant it couldn't be studied from ground-based telescopes very easily. It wasn't until 1989, when Voyager 2 arrived, that a huge amount of information about the planet has become available. Suddenly we could see what the planet looked like, confirmed it had planetary rings, and discovered a lot of previously unknown moons. But let's get to today. What do we know about this planet now? Since Pluto's demotion to not a planet status, Neptune is the 8th and furthest planet from the Sun. It orbits about 30 astronomical units from the Sun on average, which means it's 30 times further than the Earth's orbit from the Sun. 30 astronomical units, in other words, is 4.5 billion kilometers. And from that you can see why it would take a space probe using current technology 13 years to reach Neptune. 4.5 billion kilometers is a considerable distance. Because of this long orbit, it takes a huge 165 years to orbit the Sun once, which means we've only seen one Neptunian year since its discovery. This distance from the Sun means the average temperature on Neptune's atmosphere is very cold, -201 Celsius. Its axial tilt is 28 degrees, meaning it's similar to Earth and Mars, which have 23 and 25 degrees respectively. This means it has seasons similar to Earth and Mars too, the big difference being these 4 seasons last 40 Earth years each. At this moment in time, the southern hemisphere is experiencing summer, and during this summer, the southern hemisphere has actually gotten brighter, thought to be the result of interactions with the Sun, which is strange, as you would have thought that because the Sun is 900 times dimmer on Neptune than on Earth, from that distance it wouldn't make much of an impact. But even if it is only a small impact, it does make an impact nonetheless, and the brightening of the southern hemisphere is thought to be due to the southern hemisphere warming up by about 10 degrees centigrade compared to the rest of the planet. This comparably higher temperature has released frozen methane gas into the stratosphere, whereas elsewhere on the planet it remains frozen and stays deeper in the troposphere. Just a recap of the spheres of a planet, the troposphere is the lowest atmospheric level, followed by the stratosphere. Above those layers are the mesosphere, the thermosphere, and then the exosphere. But that's a very interesting topic in itself, and we'll save it for another video. If you look at the weather on Neptune, it actually has the fastest wind speed of any planet, with wind speeds blowing westward on the equator reaching a staggering 2,160 kilometers per hour, nearly a supersonic flow. And interestingly, most wind travels retrograde to the rotation of the planet. Bands are also formed on the planet, as well as colossal storms. When Voyager 2 passed the planet by in 1989, it saw the Great Dark Spot, a storm about the size of Earth passing through its atmosphere. It also saw the smaller storm called the Small Dark Spot, south of its bigger sibling. As Voyager 2 approached Neptune, this smaller storm changed in shade from dark to light. When Hubble was launched, astronomers were curious to see the fate of these storms, to see if they were a permanent feature like Jupiter's Great Red Spot. but when Hubble was pointed at Neptune in 1999, these storms had completely disappeared, and storms have come and gone ever since. Giant, bright, high-altitude clouds also come and go. But why then doesn't Uranus, which is very similar in composition and size to Neptune, also have such a blustery atmosphere? Don't get me wrong, wind speed on Uranus is fast too, but it doesn't compete with Neptune at only 900 km per hour. Can all this only be due to interaction with the Sun and its seasons? Something else must be at play here to explain the extremes in weather. I mentioned that Neptune is the furthest planet from the Sun, so you would have thought it's also the coldest. But actually, Uranus is the coldest planet in our solar system. Neptune radiates heat from within, whereas Uranus radiates hardly any excess heat at all. This could be because a large Earth-sized body crashed into Uranus billions of years ago, which depleted all of its primordial heat. Now, the more active weather on Neptune might be due in part to this higher internal heat. But what is Neptune actually made of then? Its internal structure and atmosphere is thought to be very similar to Uranus. Its atmosphere is composed mainly 80% hydrogen and then 19% helium, with very small amounts of methane. It's this methane though that gives Neptune its blue colour, although it's a dark shade of blue compared to Uranus's cyan. Again, like Uranus, there's a liquid mantle of water, ammonia and methane ices surrounding the core, and where the core and the mantle meet, the pressure is so great that the methane may break apart and diamonds are formed under the pressure. Likely not diamonds as you or I know, but there could be a liquid carbon ocean with solid diamond bergs floating in it, and diamonds raining down through the mantle like hailstones. This is just a theory though, as technology is only just starting to approach recreating such pressures. Around the core of Neptune is thought to be 7 megabar, or 700 gigapascals, which is about 7 million times the pressure of Earth's atmosphere at the surface. Even the two ice giants' magnetospheres share similarities. Neptune's magnetic field is offset 47 degrees relative to its rotational axis. When Voyager 2 discovered this about Uranus, the first theory was that it had something to do with its unusual axial tilt. But then it found the same thing out about Neptune, which has a more normal axial tilt. So the current theory is the magnetic field is either not generated in the core, but rather by an electrically conducting liquid mantle, or that the mantle deflects the magnetic field from the core, which gives it this weird offset in relation to its rotational axis. Every planet in the solar system hasn't actually got a perfectly aligned magnetic field. Even Earth's magnetic north is different from where the North Pole actually is, but it's only Uranus and Neptune that have such a tilted magnetosphere. Aurora do exist on Neptune too, but they're unusual to what you might expect, as they're extremely faint due to particles not getting as charged from the Sun, and because of the direction of the magnetosphere, they are mainly type B aurora, or SAR arcs. Earth does get these too, but they're not visible, and you need scientific instruments to know that they are there. They could be stretching across the whole sky without you actually knowing about it. The difference with SAR arcs as well is they are not around the poles, but rather around the mid-latitudes of the planet. Zooming out from Neptune a bit, we come to its ring system. Like all the other gas giants, Neptune does have a ring system, although it's very faint as it's not as dense and it's extremely dark in colour. If you have these rings against the black backdrop of space, and also be this far away from the Sun, and they're very hard to see. But there are 5 known rings in all, and they're named after people involved in the discovery and research of Neptune. The innermost is the Gale ring, very faint and very wide at 2,000 kilometers. Next is the first bright ring, Le Ferrier. Although it's bright, it's only 113 kilometers wide. Next and connected is the Lassell ring, a very faint band 4,000 kilometers across. On the edge of this ring is the Arago ring. It's slightly brighter than the Lassell ring and is less than 100 kilometers wide. Lastly is the outermost and the most researched ring, the Adams ring. It's only 35 kilometers wide, but it's one of the brightest rings. It is particularly interesting as it is slightly inclined and has bright arcs in it. These arcs have been quite stable since they were first observed in 1980, but usually planetary rings are uniform throughout. These arcs must be material clumping and clustering up within the ring, but the reason for this is currently unknown. Lastly, I want to talk about the moons. Neptune has 14 known moons, which are named after water deities in Greek mythology. The most famous, and the biggest by far, is the moon Triton, which actually contains most of the mass of all of Neptune's moons put together. I personally think it's one of the prettiest moons in our solar system. It has amazing patterns, and its burnt orange colour. What is most interesting about Triton is the fact it orbits in retrograde, and also as an inclination to Neptune's rotation, which implies it is probably a captured object and not something that was formed alongside Neptune. Triton might be the cause of the rings of Neptune, as it would have disrupted the orbits of moons, possibly causing them to collide and break up into what is now the rubble of the rings. Triton is even bigger than Pluto, and also has a tenuous atmosphere. Voyager 2 even saw faint clouds on its flyby of the moon. The next biggest moon is Proteus, which is actually bigger at 400 kilometers across than the spherical moon of Saturn, Mimas. Why it is not a sphere is explained by past collisions with things hitting the moon, leaving these massive craters which you see. The inner regular moons orbit around the rings, some acting as shepherd moons. The outer irregular moons are all likely captured moons. Some of the irregular moons orbit prograde and others retrograde. The outermost moons of Neptune are Psamathe and Neso, and are the furthest out satellite of any planet that we know of to date. They take a massive 25 years to orbit Neptune only once. This is because Neptune has a very large hill sphere. The hill sphere being the sphere in which the planet's gravity overcomes the gravity of the Sun. It has such a large hill sphere because it's already so far from the Sun. The Sun's gravity has less of an influence around Neptune than at the biggest planet, Jupiter.